Hi, kiddos. Welcome to class. I may or may not be sitting in front of you. If I am not, it is because I'm at the doctor. And if I am, what's up? So because I can't be there for both classes today, I decided that I was going to film the lecture for you guys. So that way we still, are getting the notes, and you don't have to freak out. So here are the notes. So we're going to be talking about graphing. So what we want to talk about first is, do all the teams agree about mass and weight, the relationship between them? So if we look at some data, I think this is actually data from last year, um, we can see that just like your groups, um, everybody was pretty much around the same number, but nobody agrees completely, um, except for these two groups. And there is a reason for that. So first of all, remember that there is always going to be natural variation in an experiment. So not everybody's going to get the same answer. So this natural variation is caused by lots of different things. It could be limitations with the tools. It could be limitation like human limitations. Wow, that's horrible handwriting. Human limitations, all that sort of stuff. So there's always going to naturally be some variation. So it's pretty normal to not get the same answer all the time, especially when we're talking about physics and precision, right? So the idea here, also just to kind of go back to this for a second, the idea here is that you all are getting approximately the same answer. If we were to average this out, it would approximately come out to an average of about 0.01. Okay. And this is the multiplier that we use to multiply against the mass. So if we multiply this multiplier by the mass, that will give us weight. So if we have a mass of 500 grams, multiply it by the slope, this multiplier, 0.01, that gives us a weight of 5 newtons. The reason this comes out this way, and we'll talk about this actually in a little bit, is because there is a consistent average acceleration of gravity that everything on the surface of Earth gets pulled by, and we'll figure out what that is. But you guys are really close to it. You've pretty much almost nailed it right on the head. And I'll show you the actual number is later. We'll talk about it. We're just not there. So what is a graph? A graph is a thing that shows patterns and relationships between data, between measurements. So what does this graph here tell you? This graph here is showing us that the independent variable is time on Facebook, hours a day. So, and that's comparing that to the average IQ. So if we are changing for each person, we're exposing them to Facebook for more hours every day. The more hours we expose somebody to Facebook, the lower their average IQ goes. That's what this graph would be showing. Whether this is a real relationship or not is not really the point. The point is that this is the independent variable here, and the dependent variable, the thing that you measure as an outcome, over here. Oh, here we go. So, independent variable is the property controlled by the scientist. An easy way to remember that is by saying I change the independent variable, the IV. I change the IV. I. Independent variable, I change it. I is in the experiments for the scientists, whatever. Dependent variable is the thing that you measure. It is the outcome. So just remember this as the measured outcome of an experiment. So like in this last example, our measured outcome is the IQ. They were measuring that. They were probably administering an IQ test to measure the IQs of the people as they expose them to different amounts of Facebook every day. So how do we draw a graph? Well, we need to choose a scale that's going to include all of the measurements. We need to label the axis, including the scale or the units. Yep, the units are there, and what was measured. We need a title, what is being compared. So for example, in like that earlier example with the Facebook thing, you're pretty much always like one rule of thumb, easy thing to do is just say my graph would be IV versus DV. So you just replace this with whatever the variables are. So in that case, the independent variable was Facebook usage, right? FB usage versus IQ. So that summarizes the whole graph pretty quickly. It's how much use somebody gives Facebook and their IQ, right? So just take your independent variable versus dependent variable. It's a good name. It's not very creative or catchy, but it works. And then you're going to connect all the points with a smooth line or curve. If we're doing this in Excel, which I expect you guys to be able to do Excel because you're high school kids now, we're going to learn it. When in Excel, this means trend line. Okay, use a trend line. Don't just pick the type of graph that shows you. So for example, this is the data from the lab. When I do this, don't just pick this because it already has a line. That's not a trend line. We need to add the trend line to it because the trend line actually means something. It has data and stuff. And we can see that with the equation. That's the important part. Yeah. And I'm going here. Okay, so use a trend line. Very important that we use trend lines. And I believe that is it for today. Oh, no, it's not. Oh, goodness gracious. There I am lying to you again. So, an upward slope, we would generally say as x, the independent variable, increases, the y, the dependent variable, increases. Another way to describe this is by saying this is a direct relationship. Okay, there is a direct linear relationship if it is going up in a straight line. A downward sloping line that is straight. So if you have a graph, not like this is that's like an exponential sort of thing. But if you have a graph that looks like that, this is an inverse relationship. You could call this an inverse as well, but generally you'd want to also say it's like a inverse exponential or something, whatever. You won't see that very often in this class because we're algebra based. We're not getting into like that sort of upper level math, so don't worry about it. But the line gives you y equals mx plus b. That is the relationship between the y and the x. So if you can if you, for any x, I know the y. So if we go back over here, I have this equation here. Let me copy this over to my drawing pad. Okay, so I have this equation here. Y equals 0.0104 x. And I'm cutting off the b here. We don't need b. The intercept isn't very important. So basically, if I say, okay, I want to know how much is 450 grams in newtons. So I input the independent variable, which is the x-axis, the mass, right here. So 0.0104 times 450 grams. Okay, and that will give me the weight. So if I pull up the calculator, .0104 times 450 gives me 4.68. Perfect, it's already in 3 sig figs. 4.68 newtons. Woo! Super fun. That's what that means. It's just like you plug in an x value and it gives you a y value when you multiply it out. So that's literally it. Graphs are super fun. In my next video, I will show you how to do some practice problems on the homework.